Here are the solutions for the mock exam for sequences and series. Um, a theater has 20 rows of seats. There are 15 seats in the front row, 17 seats in the second row, and each successive row of seats has 2 more seats in it than the previous row. Okay, so if you can imagine from our investigation, we had those little shapes, those trapezoids, and basically what we have is in the first row we have 15 seats. In the second row we have 17 seats. Okay, and the last row is the 20th row, so our width of the trapezoid is 20. Okay, all right, calculate the number of seats in the 20th row, which is the last row, I guess. And remember, you're going to have the formula sheet, and the formula sheet tells us for um, the arithmetic sequence, which in this case, it is an arithmetic sequence. The reason why you know is because it says that each successive row of seats has 2 more seats than the previous row, so it's addition, right? So we have u1 equals un equals u1 plus n minus 1 times d. That's from the formula sheet. The 20th row is equal to the first row plus the 20th row minus 1, which is the 19, times d, and d we know is 2 more for each time, so it's positive 2. So now, and what's u1? We know that u1 is 15, so we have that too. So now we have all the information we need to find the number of seats in the 20th row. 15 plus 19 times 2, you want to use parentheses if you're not sure about how PEMDAS works. 53. Okay, and so 53 seats is the answer for the first one. B, calculate the total number of seats. Okay, the total number of seats, remember we figured out that the formula to find the total number of seats is equal to n over 2 times u1 plus un. This is from the formula sheet. We do not know how many seats in the last row. So there's a couple ways to do that. One is we find what u20 is. And the other is we use the other formula, which happens to be Sn equals n over 2 times u1 plus n minus 1 times d. And you can see that all they did here was, instead of un, they substituted the formula for un, which is that one. Okay, so nothing that clever going on. In our case, we have already calculated u20. They were very nice to ask us u20 before they made us calculate the sum. So S20 is equal to 20 divided by 2, because there's 20 rows, and the first row is 15 wide, and the second row, or the last row, is 53 wide. And then we can simplify that to 10. 15 plus 53 is 68. So the answer, even without using our calculator, we can already see that the answer is 680 total seats. Okay. Number 2, expand this summation as the sum of 4 terms. And they just want you to show that you know what the sigma and how you use it means. So this is an interesting one because normally we start with 0 or 1, they start with 4. So the first term is you're gonna substitute the 4 in for r, so that would be 2 to the 4th. And then the second term would be 2 to the 5th. The third term would be 2 to the 6th, and we would continue until we get to 2 to the 7th. Why did we stop at 2 to the 7th? Because the last index we should use is the 7th. Okay? And then we're going to add all these together. So we've expanded it. And the other answer they might accept is if you go ahead and multiply these out. So 2 to the 4th is 2 times 2 times 2 times 2, which is 4 times 4, which is 16. And then one additional multiplication by 2 would give you a 32. And the next one would be 64. And the next one is 128. Okay? So either answer is okay. Find the value of, and then they give us the same summation, except for now the last number is 30. Okay, so this is a little bit much to be doing by hand. So now you can use the formula for the sum of a series, and in this case, is it a geometric series or is it an arithmetic series? Well, we can tell that, between terms, we're always multiplying by 2. So that means that it is a geometric series. So then we would use the term for a geometric series, which is u1 times r to the n minus 1 over r minus 1. And this is from the formula sheet. So u1 is the first term, and we know that the first term, this is actually very similar to the top series, right? Which is 16 plus 32 plus dot dot dot. We just don't know exactly what the 30th, the index of 30 term means. And this, just to keep this straight, remember this is not index 1, this is index 4. So this is a little bit tricky, not like most of the problems we've done. U1 is going to be 16, right? R is going to be 2 because there is a multiplication of 2 between each term. And then we subtract 1, and on the bottom we put 2 minus 1. The question is, what is n? And I think what they're trying to trick you into saying is that n is 30. But it's not, because n is the number of terms. And here, the first term is index 4 and the last term is index 30. So actually, the index here is not the number of terms. To get the number of terms, you could count them up, or you could subtract 30 minus 4 and get 26 and add 1, be 27. Okay? So you could say, okay, this is going to be actually 27. Okay? And then we could multiply that out. I'm going to show you one other way to do it, which might be easier. 2 to the, parentheses, parentheses, 2 exponent 27. And that is minus 1. Okay, and then we put a closed parentheses, and we divide it by 1 because 2 minus 1 is 1, so we don't even need to do that, right? Ooh, and the answer is 2147483 Okay, on the last one, they give us one last possibility, which now puts infinity at the upper limit. And it says, explain why this cannot be evaluated. Well, I think that if you write out a few terms, you can kind of see why you can't add this up. I mean, let's say that you wanted to add this infinite series up. Is that going to add up to a number? No, because each one of these numbers is getting bigger every time. So if you add up a list of numbers where the last number is always getting bigger and bigger, it's going to be infinity. So you could give a variety of answers here, but remember that the thing that makes this impossible to evaluate is the fact that the 2 is greater than 1. So like the multiplier 2 is greater than 1. This is the main reason. Okay? You could also say things like that the sequence is growing. Okay, the geometric sequence is growing. Okay, it will add up to infinity. Okay, you could say anything like that. All right, last one. Compound interest. And remember, compound interest has a slightly different formula from the regular geometric sequence. It's un plus 1 equals u1 times r to the n. Okay, so a sum of $5,000 is invested at a compound interest rate of 6.3% per annum. Okay, now let's think. What is R if the interest rate is 6.3%? Remember, we multiply the 6.3% times 0.01 to get 0.063, and then we add it to 1. And that is the multiplier. Okay. Now it says write down an expression for the value of the investment after n full years. So we already have this formula from above, so we'll write that. Un plus 1 equals U1, and we do know U1. U1 is 5,000. Make sure you write this equation at the top so that you get 1 point just for choosing the right equation. That way, even if you mess up, when you write this out, fill in the variables, you still might get a point. Okay. What would be the value of the investment at the end of 5 years? Well, then we could say U6, because n plus 1, 5 is n plus 1 is 6. So we could put 5,000 times 1.063 to the fifth. Let's do that on the calculator, see what we get. 5,000 times 1.063 to the fifth. It's equal to 6786. In general, with the IB, we need at least 3 significant figures. We can keep 4 here. We get 6786. This is a financial problem. We're going to put 0.35. Usually for financial problems, they want you to keep cents. Okay, and this is dollars. Is that right? Yeah, dollars. Okay, so we want to give the 35 cents here. The value of the investment will exceed $10,000 after n full years. Okay, so yeah, eventually it's going to get to 10,000. When will it hit $10,000? Write down an inequality to represent this information. And again, we're going to use, this one here. We're going to put it right here. Okay, and but now they say, okay, when is it equal to, or when does it exceed 10,000? And first we'll just say, oh, it's equal to 10,000. But actually they're saying, when does it exceed 10,000? So really what they want to know is when this side of the equation is going to be greater than 10,000. So that's the inequality they're looking for. Calculate the minimum value of n. Now what we can do is we will use either graphing or logs to solve this, or maybe use the calculator. Let's see. Let me do it with the calculator first so that you can see how to do that. So we'll do y equals, and we'll put the equation in here. The equation is 5,000. Because we're interested in seeing when does this equation exceed 10,000 to the x. We put the x because instead of the n, because the calculator doesn't do variable n. Oh, and I need to adjust the step size here. Plus 1. Okay, because we're only interested in integer values of n. So, like for example, at the end of one year, we have 5,315. So when do we have more than 10,000? That would be at the end of year 12. So n equals 12 years. That would be the first year that we hit 10,000. It would be U13 is equal to 10,408. Okay. Other way you could do that analytically would be logs. So let's say you start out with this here. Okay, and the first thing we're going to do is we're going to take the log of both sides, because Well, actually, the first thing we can do is divide both sides by 5,000, right? Divide both 5,000, 5,000, and then we end up with 1.063 to the n is greater than 2. So when does that happen? Okay, so now we're going to take the log of both sides. So we'll have log of 2 equals log of 1.063 to the n. And then log of 1.063 to the n is the same as n log of 1.063. And then we can divide both sides by log of 1.063. 1.063. And then now we just have n equals log of 2 divided by log of 1.063. And of course we need the calculator to help us do that. Log of 2 divided by the log of 1.063. 11.3. Okay, so minimum of 11.3 years to get to 10,000. So if n is an integer, then you would round that up to 12. That's it.